Today we're going to talk about fraud detection and how Neo4j or how people working on new cutting edge technology look at fraud prevention. And to start off with, quick introduction about myself. Again, I'm Maruthi and I'm part of Neo4j. And if you don't know about Neo4j, Neo4j is a graph technology and we invented graph databases. And we've been here for about 15 years, roughly 15 years or so. So we've been working with a lot of MNCs globally. So I'm going to be talking less about the product and more about how graph technologies solve fraud or prevent fraud. But before that, we need to start about what fraud is and how big is the impact. So if you look at this slide, there's a lot of numbers, but the key metrics is year on year, we have about 20% increase in fraudulent activities across all industries, and which has not gone down. And if you look at overall revenue loss, if you look at it, it's in the billions of dollars and it's still growing. Just imagine the revenue of each organization year on year doesn't stay the same. It's actually increasing. And if you look at it, additionally, there's about $3.75 of losses for every single transaction that's actually happening across the globe. And pretty much post-pandemic, everyone transitioned into e-commerce and all mostly digital. That it means a majority of the transactions move from paper currencies to digital currencies, and we are more susceptible to frauds at this point in time. That's why it's more critical at this juncture for us to relook at how we have been doing fraud for the last, 4 decades or so. So when I talk about frauds, actually there's a lot of different areas you can look at. It's not just happening within financial sectors or places where money is used. Like there's also places where, if you look at it, synthetic identity fraud is quite rampant at this point in time. There's not actual direct impact on dollar signs. You're not going to lose money, but people just stealing your identity and misrepresenting you in different places, which is a big crisis at this point in time. So fraud is not limited to just financial and dollar signs. It goes beyond that. That's the key thing that we need to think about this. So going back to where money is involved, that's where people are going to be very serious about. So when 10 years ago, when people started implementing fraud solutions, they were looking at how fast it can work, because user experience was key. Because if Amazon can complete a transaction within a second, and for example, Swiggy takes about 10 seconds, they want to prefer to work with Amazon because it's much faster. It's more of an user experience thing. But then these days, what CROs, chief risk officers, look at is experience is key, but also the amount of money that's leaking at this point in time. If you have a leaky bucket, it's not also good for business. So we're actually moving from speed and accuracy, and we're moving and focusing on the area called as coverage. I'll actually go into in depth about what I meant by coverage at this point in time. And fraud actually goes beyond, as I said, dollar signs, right? There's a bigger and wider impact. First thing, as a business, it impacts you from a revenue perspective, and also from safety regulators perspective. They're not going to trust you. And recently, there's a lot of FSIs, or financial services institutions, who've been banned from onboarding customers online. So, which is actually growing as a big problem for businesses. The next thing, customers are first going to lose trust in you. They're going to lose money, and also they're going to lose credibility. And the last part is also branding. So branding is something like most organizations are competing against, because there's a lot of service providers out there. So if you lose your credibility, no one's going to trust you, because there's 10 other service providers competing against you, doing the same service. So branding is very critical, and it's not just one event. It's going to span across time. So we start with looking at the past, or the old technology that's currently being used to prevent fraud. So what I call as like the boxed up space, where who here has not worked with relational databases or never seen tables or Excel sheets before? I hope everyone has seen that, except for the gentleman on that side. But then when we look at tables, rows and columns, and relational database systems, right, we actually always start with, hey, I have a customer, and the customer is making a transaction, and I start splitting. I first create a customer table, which is on the left side, and create a transaction table on the right side. And at the bottom, you see another table, which you can use for all the different products they're buying. But then in actual life, when a transaction happens, I go online and make a purchase. It's not so disparate. It's actually all connected. The information is connected. But when we start storing this information, the technology we have, we start separating them, and we lose a lot of information. That's why I call it the unfair exchange. You want to have something in a place where you want to store information in a structured way, but you start losing all the good information that is already generated. You're not enriching, it's already generated, but you lose it when you store it. So, but then what are we exchanging it for? We're exchanging it for tables, keys, and joins, and more joins, and a lot of joins, and it goes on forever. So what happens when you start storing all this information in a table, right? You're limited by how the information is represented to you and the person trying to use the information to take some actions. If I now take the two tables, one is a customer table, another transaction table, and I plot it across a two-dimensional unit, it's going to look like this. And most of the time, you're going to look for anomalous transactions, which is either above average or below average, just saying this. And this is, all these transactions are cleared, and it goes off. And this is how we actually do analysis at this point in time, which is kind of a discrete analysis, or you just look at discrete data points, like individual data points. But fraud doesn't happen at individual data points. I'm not like, today I'm going to do fraud, I'm just going to go in, log into Amazon, just do some fraudulent activity and exit. I plan it, I do it across time and make sure that I don't get caught. So most of the fraudsters, they stay within this and they don't get caught because they're not tracked as anomalous activities within the system itself based on how we're looking at data. Beyond that, one of the key challenges is your data is not going to be able to tell you good information, because over a period of time, fraudsters are always going to be making transactions of $10 or above $500 to constantly defraud the companies, right? They're going to like mix and match. They're going to move around. They're going to be very dynamic in doing things. That means you need to constantly analyze your data, trying to figure out what's happening. So it's going to be very hard and it's a complex problem for you, because you're going to try, is it like Maruthi, just me, transferring to someone over here? No, it's going to be like, I transfer to someone and someone transfer to someone. Like, just imagine yourself like 20 people in the room, everyone is transferring, making transactions between each of them. How are you going to write the query? How is the person looking at the data going to think about a scenario where 100 people are involved in a particular fraudulent activity that's happening? So that's a big challenge, and the current structure of tables and foreign keys and primary keys to join information doesn't work. And the most challenging part, most of the developers here, including me, when I started writing SQL, I start with this, because I start with my first join, user A, transaction 1 with transaction 2 with user B. But then it doesn't stop there, because it's much more complex and everything. Then I continue with this. I go in for another few hundred more lines. It stops here, but then the fun part comes in, because by the time I execute it on my SQL workbench, I have two things in my head. The first thing is, should I go for a movie? Should I go back home? Should I like cook myself something? But this is not the worst of things, because I can still take a nap peacefully, come back after a sweet dream, and still enjoy my coffee before checking the results. The worst part is this. I execute a wrong SQL query. It's going to run forever, or worst case, it's going to bring down a whole cluster. My manager is going to call me. Most probably, I'm going to get fired. So my head is always like thinking about whether it's going to work or not. One part. The other part is, am I going to kill the server? Is people going to be mad at me? So these are kind of like the common things working with SQL or relational database has been, right? Apart from the fact you're not trying to prevent fraud at all. You're still trying to solve problems, which is not very important to business. That's where we move into present in the graph world itself. So we talked about boxes, but then if you want to move out of boxes, what else we can do? So that's when we thought about, can we have circles and arrows? Different shapes. There's a lot of shapes in the world, right? So we just moved with circles and arrows. So circles and arrows are a representation of graphs. So graphs, I know, might be a very new concept, right? But it's very simple, very, very simple. There's three main things. The first one is a node. A node can be used to represent an entity. So entity can be a person, a building, an object, an animal, whatnot. And the next part is a relationship. This is kind of like the secret sauce for me, because as I mentioned, we start losing information while storing, not while the information is generated. So when we start storing, now we are able to capture the information of the relationship between two events and a particular interaction. A customer making a transaction. So that particular part, the relationship is captured using that particular arrow over there. The next part is the property, because every time a particular interaction happens, an entity is captured. You need to understand what kind of entity it is. So all your attributes go in as properties over there. So that's about graphs, as simple as it. It's much more simpler. If you look at it, I had 3 tables with a lot of boxes inside. Now suddenly I only have 6, 7 circles and a couple of arrows. I have more context to it. So in the key aspects of it, as I already mentioned, is context is very key of why this particular event happened. What happened is why and what is captured in the data set itself. Next thing is already connected. As I said, fraud doesn't happen in a singular point in time. It happens over a period of time. So you need to be able to connect and look at across time and how the pattern looks like. And the last part is patterns. Because in graphs, we are going to look for different patterns. The pattern can be fraud happening within 3 people or the fraud happening between 100 different people. It's still a pattern. So we are able to scale and look at very complex activities and how they are running. So the same graph, we look at it, we are plotting across X and Y axis. But then at this point in time, we're not looking one particular event. We're actually looking at events across time by connecting them because the data is already connected when you store them in the graphs. So as you see, we're not looking at a pattern which is anomalous outside average or below the radar, right? We're actually looking through the entire transaction and figuring out, hey, actually, all these events are connected, happen in a particular sequence, and they seem very, very weird because all the other customers, they have not made some kind of like very similar pattern transactions, right? So then I'm able to kind of identify new kind of fraud patterns instead of me trying to figure out is like imagining a particular kind of fraud happening, because not all the time you're going to hire a fraudster and add them to your risk team, right? You need to be creative and figuring out. So in this case, when you have connected data and you start looking for patterns, and those patterns are scalable from, maybe as I said, from 3 users to 300 users is going to be same pattern. You're able to quickly figure it out. So you're able to have that wider coverage, which I mentioned. So now you're not looking at those 10 people who have made $5 million transactions. You're looking at also 100 people who have made 10,000 transactions of $500. So you're capturing a wider group of pool who are like slipping through your grip. So key thing is when I mentioned in graphs, right, we are currently exposing all the information in a very explicit way. As I mentioned, customer A making transaction 1. So we have made it explicit using relationship. But then there's also more implicit information available because as a person who is going to like say 10 different e-commerce sites, explicit information is Maruthi visited 10 different e-commerce sites. But the implicit information is I spent a lot of money on e-commerce. So that's an implicit information that's already available. When you use graphs, you're able to, or when you look at connected data, you're going to be able to kind of uncover all this information. So within graph itself, the good part is once you uncover an implicit information inside, you can make it explicit. So that's where the power of Cypher queries come in, so which next slides will cover. And the next thing is, if you're looking at a pool of 100,000 customers, it's much easier. You can get 100 people looking through 10,000 transactions or so to find fraud. But then if you're looking at million users, 10 million users doing billions of transactions over a year, how easy is it for us, kind of an analyst or a subject matter expert, to identify fraud? So that's where graph machine learning comes into play. So graphs are really good at patterns, and applying machine learning to that, actually you get more, I would say, accurate information. So you reduce your false positives. And also this covers your coverage. So how do we do that? So in SQL, RDBMS, you use SQL for doing it. And I said like, we write a lot of lines of queries. But when we move to Cypher, which is very pattern driven and it's very expressive, you can actually scale your queries by applying the pattern. Over here, what you see is actually a pattern which you can execute, which looks at a particular account that performs some form of transactions, which benefits to someone. So in this case, I'm not hard coding like I need to connect 3 customers and look at particular transaction, but all I'm saying is as long as a particular pattern of money moving around and someone is going to be a benefactor of that, retrieve it. And this can span across million users and it's going to help you retrieve it. And the query is as simple as that. You're not going for a few hundred lines. So this is the expression I get most of the time. Yeah, sure.
Probably it's really basic, but when we find that the question like at least you can update this with that's it is not right for updating correctly. So here you're be in the how we are managing the volume.
Yes, so when you talk about performance issues, right, there's a lot of different stages. Like one that can be a database issue, but there's also a huge process on your ETL. So your performance tuning needs to be done, and you need to look at whether are you doing the right graph modeling, are you doing the right ETL strategy and everything. So we can take it offline and go deeper, but data I'm going to, one of the slides is actually a real life example of where the graph sits behind the e-commerce payment transaction, where users press buy. Within a second, it goes through the payment gateway, does the fraud analysis, and actually the transactions go through. So this happens across millions of products being sold real time. So I'll show you the example in a bit. So this is exactly the slide. So this example is actually around merchant trade fraud. For e-commerce platforms, when they actually onboard new merchants, they actually run a lot of promotions, actually giving them money out of their marketing budgets. So as you start selling products on your platform, every product you sell, maybe you get a $10 rebate. They actually start giving it. So what happened in this particular e-commerce platform provider is like, I set up a particular shop and I sell iPhones. And I actually also create multiple other accounts and I buy iPhones for myself. So technically they start selling 100 iPhones while they have 0 iPhone as inventory. Nothing is moving around, but they are making money by all this marketing budget which is being provided by the platform provider. So in this case, we did a real life example. This is actually just a small subset of the graph, this data model over here. But we were going through about 1.6 million users and about 400,000 purchases and trying to figure out whether it's a fraudulent activity or not. And this was being done real time on the backend system. The moment the user clicks purchase, we run this. And the best part is we have gone through a volume of 1.4 million users and 400,000 transactions. When you look at the permutations, it's a lot. But then at the end of the day, the result was there was no fraudulent activity. Just imagine a customer who's waiting for this to happen every single time. And as your customer base grows and your transaction volume grows, and actually this is not a fraudulent activity, your customers are not going to be very happy. The user experience impacted greatly. And as I said, there's always an alternative. People can just move into another provider and can just buy. So this is one of the key things about how graphs vary and how they actually perform way better than traditional systems. So one of the key things is like everyone trying to look at graphs like, hey, is this new technology? Can we bring in data? How are you going to be able to model this? And how are you going to integrate back into your ecosystem? Like we already have built our tech stack over the last 2 decades. So it's a very simple answer. Neo4j at the end of the day is actually a database, and we are a very mature database for that. So you just need to lift it and drop it in the right place within your current tech ecosystem, and you're going to be able to integrate using any traditional like JDBC, ODBC integrations, your standard ETL pipelines, or even like if you're working with Spark, Kafka, we have connectors for all of that, and it's quite mature. So you're able to stream in data, do batch processing. You can build a dashboard application on top of it, or you can actually just build a real-time fraud detection system as well. So all within the same machine. So we're kind of a hybrid database, both on OLTP and OLAP performance. Pretty good. With that, just quickly covering. So with this overall thing is like we are definitely helping improve and evolve fraud applications, right? Because we're not just looking at static information or singular events, and we are constantly evolving over a period of time. And as we look at patterns rather than just setting up weightages and also like what is the threshold to hit and everything, we're also very scalable, not just from performance and data volumes, also from a fraud perspective, looking at different patterns. Again, it's like problem solved. We already like looked at how different graph databases and how efficiently they can solve problems, and they can continuously evolve as fraudsters evolve. So I think I was ready to go on vacation. Like everyone was really happy. So I found this gentleman, I sent to my clients, okay guys, let's set for vacation. But then what happened is 2 years ago, ChatGPT came into play and generative AI went mainstream. But then not only the good people who want to actually write their resumes or the resignation letters, but people who also want to commit fraud started using it. And we look at across the world, it was not widespread until the media took it up and they started spreading, hey, actually you can use it for fraud. Now everyone knows about it and everyone wants to explore that, and suddenly there's an explosion of new and more innovative fraudulent activities happening. So then we wanted to get back into action. So we were like looking at all the bad guys from Cartoon Network. They were like, wow, they are very happy, excited about the new ways they can fraud someone. So we need to start looking at new ways of stopping and preventing it. So it was like more of like, we have this amazing tech stack and we are competing against people who are using ChatGPT or other generative models specifically trained to actually help people do fraud. And now they are supercharged with certain piece of tech that current existing users don't have. So how do we start working with it? So what we decided is like, how can we supercharge our own knowledge graphs, our own graphs? And we started looking into it. So the first thing we did is like every other database vendor out there or technology vendor out there, we looked at the most commonly used frameworks or blueprints. So the first thing we came across was something called RAG, Retrieval Augmented Generation. So then we started exploring, this looks very promising. So let's start working towards that. So the first step we did is like, how do we get data out of the graphs, or how do we get insights out of the graph very quickly, because that you already have all this rich piece of information, and how do we start making better actions based on those insights? So we started building a RAG mechanism on top of it, and vector database was one of the key things that we started looking into. So we have explicit information that's available in the graph because you already stored your relationships inside, but now you also want to have some form of implicit information which comes in text. So in your text descriptions, you might be able to find it. So you wanted to have something like a vector search, so it comes close to a semantic search. So we also implemented a vector search machine and then combined both of it. So every time a user starts accessing the graph, now they're going to look at the patterns and also the semantic information and combine them to have more accurate information about what kind of activities is happening within their particular business itself. And then the other part we also looked at is like, how can we improve the information going in? One of the key things the gentleman said is like, there's performance issues. And the other part is also like, you constantly add more data sources. How are you going to be quickly able to kind of incorporate that back into a knowledge graph? So we started looking at using LLMs to actually build graphs using LLMs. So you pass in unstructured data or structured data, and using that, you are able to analyze and able to build kind of a template to actually ingest those new data sets into your existing graph. So you continuously start enriching those pieces of information. With that, we went to the next step of actually having more of Gen AI powered language models, or language models powered by Gen AI to actually support knowledge graphs and see how we can enrich all these pieces of information and also kind of like scale things out. When I say scale, it's not just performance and the data volumes again. It's more on like you have new frauds coming up on a daily basis, new patterns emerging. How can we leverage this RAG mechanism and the mechanism to build knowledge graphs to actually expedite so we can be on the front foot rather than actually reactively trying to prevent it? So that's where we stopped. But then as we started working with more and more clients, we realized like having just RAG and having a system to actually just load in data was not enough. So we like started kind of like collating all the pieces of information that we gathered from our research and also working with clients and see like how can large language models kind of like make things even better and like put us like 10, 20 steps ahead of everything else. So if you look at it, we decided not to use LLMs for as like a sledgehammer or a bulldozer to break through things, but rather use large language models as precision tools for specific focused activities. So you're able to constantly scale your system at every step of the way because there's always a life cycle to your application, also to data. So we started like leveraging LLMs from data enrichment to data processing, data engineering, and also down the line, how do you integrate with different applications? Because you might not just build a fraud application at the first go. You might just start with simple dashboarding, and then you want to scale out from use case 1 to use case 2 to use case 3, and you just go to use case N, right? How are you going to be able to scale it quickly? So we started using on the downstream also different forms of LLMs, kind of very targeted towards a particular activity. So then we came up with this blueprint and which kind of like being implemented across most of our clients. So this helps them move from 0 to 100 within weeks, and they're going into production, and this is able to scale because they're not limited to predefined functions or predefined patterns. As the data evolves, the system evolves, because now we have the context which can be provided to the LLM rather than just 10 transactions goes into LLM trying to figure out what's happening. So just wanted to cover 3 customers like on 3 different areas. The first one was around speed. So we're working with banking circles. They actually provide infrastructure for financial service institutions. So they started working, and they are providing infrastructure for FSIs. That means FSIs need a lot of speed. And now they're not just providing for one, they're providing for multiple. And that means they need to be able to scale and also be very fast in responding back to it. So they actually found that working with graph technologies, merging it with LLMs or map, working along with LLMs, you are able to improve their fraud detection by 300%. So that was like a huge leap. Just imagine your infra cost is not going up by 300%, or you're not kind of like expanding a team by 300%. You're just implementing a new tech, which pretty much captures the information which is already there. And then you're just enriching it with LLMs to actually make it work better for you. The next one was around accuracy. The other big challenge is you have billions of transactions for larger enterprises, and there's millions of users. There's always going to be anomalous activity. Even during pandemic, the biggest thing was like people can't go out, so they just log into VPNs and just order from other countries. Like the place where I live, I can't order from Amazon US, so I just go to VPN, just order from Amazon US, but then suddenly my credit card provider blocks me because I'm living in a country, but then suddenly I'm showing up as a person who's living in US. So it's an anomalous event, but in actuality, it's not a fraudulent activity. So how do you stop it? So triage of all this false positive things is actually pretty good in graphs. So that's one of the other use cases we worked on. The last part is actually coverage. As I mentioned, like everyone, the CROs or chief risk officers approach of looking at fraud has changed from speed and accuracy to actually coverage. So looking at all those things that's slipping across. So To-Do is also kind of a profiling system which looks at all your transactions and actually identifies things. So they actually help kind of reduce the overall false positives. At the same time, they actually look at a wider range of things. That means instead of just looking at 3 people across 100 transactions, they look at 10 people across millions of transactions across a couple of years to actually figure out if it's actually a fraudulent transaction. With that, I'm just going to quickly bypass this and just end the session with, you have most of the high-level information required for it, like re-look into your fraudulent time stacks, like fraud time stacks, tech stacks. So with that, we actually have a Bangalore community. You can actually join us if you want to learn more or actually kind of contribute back on graph tech, on new edge tech. So thank you.